Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, mathematics is in sync. No. We're going to look at synchronization. We'll see how pendulum clocks bring themselves into perfect agreement, or maybe perfect disagreement, how fireflies flash at the same time, how heart arrhythmias can naturally arise, and how birds and fish form those beautiful swirling flocking patterns. Much of my information comes from Stephen Strogat's excellent book Sync and his TED Talk of the same name. The story of perfectly aligned pendulum clocks dates back to 1665 and Christian Huygens, the inventor of the pendulum clock. While lying in bed sick, Huygens noticed that two clocks he had recently made and hung on the same beam were swinging at the exact same rate, but in opposite directions. You can see a similar sync in Strogat's TED Talk. Huygens speculated that mechanical vibrations passing from the clocks to the beam to each other were coordinating the movement. His reasoning was that if, for example, both weights were swinging to the right, there would be a net force applied to the beam that the beam would resist. The weights swinging in opposite directions would cancel each other for a nice, stable balancing effect, and nature likes efficiency and stability. Research in 2015 has shown that the vibrations creating the sync are actually sound vibrations. In 1857, travelers to Thailand returned to England with crazy stories about thousands of fireflies flashing at the same time along a river. You can see a video in David Attenborough's Trials of Life talking to strangers. Once people decided to believe their own eyes that this really occurs, the search was on to explain how the fireflies accomplish this. Strogatz and others came up with mathematical models that could produce the results. The fireflies became somewhat of an internet phenomenon, and it turns out that species of synchronizing fireflies don't just live in Thailand. The Great Smoky Mountains in Tennessee, Congaree National Park Swamp in South Carolina, and others host syncing fireflies. With these discoveries, scientists have more chances to test their theories on real data. I'll use an analogy to describe a couple of the models. Suppose you're in a crowd that is instructed to clap every second. Well, imagine you're British. Americans are really not very good at this. You have an internal sense of how long a second is, 1 Mississippi. But if you find yourself out of sync with the crowd, you can speed up or slow down your 1 Mississippi. Everyone doing that would quickly sync up. Or you could trust that your sense of time is fine. You just need to adjust your starting place to clap when your neighbor does. You're changing your phase here, not your period. This could also produce sync, and these models have been explored for the Thailand and Congaree fireflies, which left to their own devices flash at a nice intrinsic speed. However, the Tennessee fireflies have no sense of 1 Mississippi. On their own, they flash at more or less random intervals. In groups of 15 or more, they sync up, but not with a steady pulse of dark and light. They have bursts of flashes, followed by a gap, then more bursts. Something different is happening in the Smokies. The basic model developed here starts with a random flash for each fly, which then needs a certain amount of time to recharge for the next flash. In groups, however, the next flash is not so random. When a neighbor flashes, any firefly that is charged lights up. A bright cooperative group flash emerges, and then a wait until the next random bug goes off. So different species have different behaviors and require different mathematical explanations. One side note, among the Congaree fireflies are some outliers who don't sync up with the others. These are thought to be the first known examples of chimera behavior at the organism level. The chimera state had been observed in mathematical theory and simulations, and physically in the firing of neurons. The science of sync has made major strides in the last few decades, and it's not just because of the fireflies. A heartbeat is the synchronous beating of thousands of heart cells. Brain activity is based on the synchronized firing of neurons, and the list of significant applications of sync grows. Biological entrainment gives several examples of sync in the world. I'm most familiar with a highly simplified model of heart dynamics. The AV, atrioventricular node, coordinates the contractions of the atria and ventricles in the heart. In healthy hearts, The atria contract after the SA node fires, and the AV node promptly triggers contraction of the ventricles. A simple model characterizes the ventricle as an electrical circuit receiving a regular periodic stimulus from outside. That's the SA node. What is fascinating and instructive is that the behavior of the ventricle depends on the pace of the input. If the signals come too fast, the ventricle naturally strays from the healthy 1-to-1 rhythm to other patterns, such as 2-to-1, one ventricle beat for every 2 prompts of the AV node. Atrium ventricle, atrium no ventricle, and repeat. There is a precise entrainment of the ventricle to the signal, but in this case it corresponds to a dangerous heart arrhythmia. A more pleasant but less important example of sync occurs in birds. You have undoubtedly seen groups of birds flying in one direction, then suddenly swirl and make a large turn before swooping again and coming to rest in a tree. What causes those changes in direction? Is there an alpha bird leading the flock? Well, careful examination of videos shows there is not. A simple model for bird flight was devised by Craig Reynolds and named Boyd's, and reproduces the bird flights remarkably well. There's a nice demonstration of this in Strogat's TED Talk on sync. Here are the rules for Boyd flight. First, try to match the average speed and direction of your neighbors. Second, give your neighbors a little space. Third, if there's an obstacle or predator nearby, avoid it. And that's it. No leader, no global strategy, and yet it very much looks like coordinated action. Schools of fish have similar behavior, and Hollywood uses models like this to create CGI flocking behavior. Now, a word of warning, since seeing videos of Boyd's, I have become fascinated with the motions of real birds to the extent that it's a distraction when driving. Don't text and watch birds while driving. I used a hand clapping analogy earlier, and that's where I'll finish. You can find a clip of Harry Connick Jr. playing a nice jazzy piano piece. The audience is clapping along, synced to the beat. You can see, though, that Harry is a little unhappy because the audience is clapping on beats 1 and 3. Not cool. So Harry throws in an extra beat, and now the audience is clapping on beats 2 and 4, just as he likes. Well, it's all about math.